in space.
All right, so here we are. It is August 26th. We are actually have the opportunity to sit in front of the microphone and watch the Starhopper 150 meter test. Yep, it was 200 meters, but after the FAA approval went through, it went down to 150 meters. Is that a big deal? No, not really. It's really not that big a deal. And they're still going to learn a bunch of what they need for the next step. You know, Starhopper is, like we talked about before, it's basically a water tower. Hold on, I'm going to fix the camera here. That's a little better. Okay, so it's a water tower with rockets, basically, on it. A Raptor engine on it, so it's cool. We're looking at the test right now. We have a view on Starhopper, and we have a view on the Raptor engine on the right side. And there's about 2 minutes and 38 seconds on the clock here for the first test. I'm really excited about this, and it's been super popular on our YouTube channel. Starhopper is capturing people's attention, so let's talk about it a little bit more. So Starhopper is a prototype. It, like we said, water tower with a rocket on it. Why did they build a water tower with a rocket on it and not the real rocket ship? Well, today I was listening to Tim Dodd's live stream of this throughout the day. Tim Dodd is the EryDayAstronaut, was one of the first people I found online and realized that this kind of thing was even possible. He does great work. His live stream was great. It looks like we're stopped at 2 minutes here. Maybe they're holding to prep. We'll see what happens. But they built this because they need to cheaply, that was the Starship actually venting there, they need to test a rocket that most likely will blow up. One of the things that's really fascinating with aerospace is, especially when I got my degree, they made and there's a lot of engineers, but our major particularly, we had a specific class we had to all go to. It was an ethics class, basically. And we talked about various scenarios where people do not prepare properly and people get hurt. Aerospace in general, whether it's planes or helicopters or going into space. Like, all of these things have standards, all of these things have safety standards, and the level of risk, like Tim mentioned in his thing, which is 100% true, is that risk is actually calculated. It's actually calculated how risky this certain thing is. So the cool thing is, in the engineering of this, they really only needed to build this much of the rocket to test the first stage. You know, this rocket, the Raptor engine, is an extremely powerful engine, and it needs to be proofed out. You know, they haven't even fired it for a full minute, I believe. You know, that's one of the crazy things about these rocket engines is, you know, you're kind of like testing it along the way, and you only have so much money, so you don't want to really blow up a whole bunch of them. You can't just like the cool thing about having a 3D printer and 3D printing out of like plastic is it's actually really, really cheap. So if you wanted to do, I do that in my design process a lot. I will have something I wanted to make, and maybe it needs to fit something. Maybe it's a replacement part. Like there was one I did. It's a replacement part for a knob on an oven. You know, the company doesn't make it anymore. The knob broke or it snapped off because it's super old plastic. We remade a knob and I printed a whole bunch of them to kind of fit it. So we designed it, and then once you 3D print it, it's not exactly 100%. So you build another one, and the good thing is plastic is cheap, and when you own a 3D printer and you've already paid it off, that's just another tool in your tool chest for design, and it actually lets you design extremely quickly, and especially for the actual machine that's making it. Rockets are obviously a little bit different. With rockets, we only have a certain amount of money. It's super expensive. The technology hasn't been made before, and so only getting like 5 of them is so expensive. You know, the reason why things are so cheap is because they're mass produced, especially plastic stuff. Like if you have an injection mold and you're making 10 million parts from that mold, that one part is very cheap. But if you're making one of them, and that's one of the things, like when you're prototyping, is that it's very expensive to do so, and it has been until the last 20, 30 years. 3D printing has been a big part of that. 3D printing helps us achieve the end result with more attempts and fixes and tweaks on the real thing. It's one of the great things about having a prototype is you're able to slowly tweak it as you're making the final thing. So you're learning even more. If you have multiple prototypes, if you do it right, and we've seen SpaceX do this, you learn a ton, and we've seen their success with this method with the Falcon 9 rocket. So the Falcon 9 rocket, we talked about it the last episode. When I was in college, I had watched this thing completely reset. The clock is now at 1:48, 1:47, 1:46, and we'll have it launched soon. But real quick, I watched the Starhopper develop in college while I was getting my aerospace engineering degree. They literally had a rigid rocket with a rigid rocket, meaning they had the grasshopper, the legs that now fold out and they come out beautifully, and timing is like perfect. That was not like that when they first tested it. Just like the Starship here is just a Starhopper. It's not the thing that we're flying to Mars on, but it's the thing that will get us to the next stage. So the Grasshopper Falcon 9 was the test to see if this was even possible, and that's what this first test. It's a cheap test to see if this is possible. If this rocket in this orientation for the power they're looking to test, to see if the engine works, to see if they can catch the mission profiles that they're looking for, 58 seconds, it is a cheap way to do that. They're actually, looks like they're putting down water before they launch this rocket. Remember, there was a brush fire the last time we did this test. All right, so 45 seconds. So Starhopper, this is the first of these tests that really pushes how far this rocket can sufficiently send a piece of mass with control into orbit. And we are going to see very shortly what the next thing is. This Starhopper, 27 seconds, here we go. This Starhopper, this is the last test. If it survives, it will become probably a static stand for Raptor engine tests later. So they may be able to reuse this, which is even cheaper and spends less money. 14, 13, 12. Okay, here we go. Starhopper, 8, 7, 6, 5, 4, 3, 2, 1. Let's pump that volume. All right, so we got some venting up top. Looks like they stopped at 0.8 plus 0.8 seconds. There was some kind of a venting sound. It looked, I can't tell if that's the remaining vapors from the fuel just leaking or if that was around the nozzle, but it got pretty cloudy there for a second underneath the Starhopper test. Not sure what happened. We'll have to find out. Whew. All right, so I'm gonna keep that one open. We're gonna check real quick. And so this is where the space industry is right now. This is such an interesting thing. Thinking about where's the value in space science communication. Right now, someone like Tim Dodd, someone like what I'm trying to do now, what I'm trying to start up here, is communicating this stuff that we're looking at all the time in a way that a lot of people can actually see it. Because following this stuff, I have multiple apps and we are constantly checking stuff online, and there's Reddit thread. Thank God now there's Reddit threads, and in Boca Chica right now, Texas, where this is happening, basically the Reddit threads are people that live in that town that are sharing this information. Like the sheriff gave a warning to everybody that, hey, that's how we kind of got keyed on the fact that the FAA approved this, that the sheriff went by and gave a notice to the people in the town. That's what I had seen online. So that's how this communication is happening. It's happening in person, and it's just being relayed right now to people online so that we can share it. So there's so many middle voices that can help share and spread science, especially at the local level. Right here, this is Boca Chica is gonna experience and is starting to experience a huge uptick in how many people want to live there because of this right now. And they're going through a total transformation as a town. It's just the sound of venting. No action here on the screen. We're still at 0.8 seconds. But yeah, that whole town of Boca Chica, Texas, and I think it's Cocoa, Texas too. All these areas where all this Starship stuff is going to happen over the next 10 years or so, that we'll probably see Starship develop. This is the early stages, and here we have SpaceX. Their screen just changed, and the test aboard just after T0. The teams are evaluating the next test opportunity. So it's kind of wild, actually, that we were talking about cost. They stopped the engine right before because something wasn't quite right. So they're going to save the engine and go back and see what they need to do. That's the life here for aerospace fans, for space fans. Rocket launches, test launches, sometimes they don't go quite well. We've had plenty of those here on the podcast over the years. So just like every other time that a test gets aborted and nobody's harmed, nothing is exploded and destroyed and basically a bunch of money lost, we saved it. So good thing is that means we're going to have another opportunity to see this water tank fly. The Raptor engine actually lift a decent amount up and actually be able to see it in the sky and see how it's operating, see how it's maneuvering that mass in 3D space. It's going to be really interesting. So thank you for listening, and we'll move on to this week's next segment. All right, space people, so it is day 2 for the Starship Starhopper test, the Last Starhopper. We have here the 3D printed version of the Starhopper. It's a pretty amazing Thingiverse file that was for free thanks to the designer Astronaut on Thingiverse. So you can check out the actual assembly of this on our Instagram pages at Today in Space Pod and at AG3D Printing. You can see this get 3D printed as a time-lapse. You can see how we assembled it and just get a cool thing, get some cool music in the background from us. But we are now talking about the Starhopper test. I just got home from traffic. It just happened 40 minutes ago. I'm about to put it on. We're at 2 minutes. Let's jump right into this. I'm so excited for this. Okay, so, when we left off yesterday, we talked a lot about, the fact that this is a cheap way to develop a rocket. It's a cheap way to make a test so that you can work on it. It's not the final thing, and it's probably going to be very different. But what we have is a good test specimen, just enough to test what we need. We've got a Raptor engine. We've got a structure that's kind of simulating it. It's at least simulating a lot of the weight that the engine needs to be able to maneuver, and then they'll tweak it from there. And it's very fun to watch this happen. Like we were talking about before, the Falcon 9 tests were amazing. I really didn't want to repeat myself today. There was just so much to cover. And, if you listen to that last segment, the audio was a little off. I had my AirPod still on the ground, and it recorded through there. So we used the audio on the phone. It's all good. We've got a minute left. I've been looking forward to this all week, and today was a bit of a rough day, so I am just pumped. So what if we lost 50 meters out of the 200 that we expected? We're at 47 seconds. The water's starting to lay down underneath the Starhopper test. This is what's awesome about being able to iteratively design and develop something today and not have to wait the 10 years it takes to get to the point. And maybe it still will take us 10 years. Starship is a crazy project. We're 25 seconds. It's a crazy project of a spaceship that will bring us into the stars by the hundreds, or up to 100. So we've got 15 seconds left. We've got Starhopper venting. We've got everything ready. 8, 7, 6, 5, 4, 3, 2, 1. Got ignition. Alright, we've got storm cloud. There it comes. It's flying, man. It's a water tank and it's flying. Alright, so I'm seeing a little bit of, I'm seeing the tower tilt. It's maneuvering to the left. The rocket is adjusting to try and keep it going up and not keep hovering as far over. I'm not sure if that was the original plan, but it's going up, it's going to the left, it's using actuators, air to help move it, it's helping it turn as it's launching, and now it's going back down. Oh my god, that engine is so powerful. And here is almost a minute into launch. 57. And that, ladies and gentlemen, 57 seconds and 57.36 seconds. The 150-meter Starhopper test is complete. They have successfully made a water tower fly. There's a beautiful view of that. And that's what we've got right here. The last Starhopper, everybody. This is the last, I want to say a Starhopper, like for Boston, but I'm trying my best accent. A star, the R's are hard. Starhopper. So, it's the last Starhopper. This is it. This is a successful prototype that will now be inherited to become the static test stand, hopefully, of the Raptor engine moving forward. A completely new engine, just literally hovered a rocket up, it went over, it kind of spun a little bit, and then it's made its way back onto the ground. That is success. That's a huge milestone. Congratulations, SpaceX team. Congratulations, Elon Musk. Congratulations, human race. We have another successful step of a pretty insane spaceship that may be bringing us to the moon, to Mars. If this is ready, this could be our Artemis 2024 spacecraft, but there's a lot of work to do. Again, just a water tower. It's not anything more than that at the moment, but it has rockets on it. So that's it. We're going to end that for this week. Thank you for joining us for Today in Space. There was, it's cool. We've done a lot of launch coverage over the years. Sometimes in my car, just watching the phone and recording on something else. This time, just got out of traffic and saved it. I tried to click the moon so that the Do Not Disturb button, and I still ended up getting a space spoiler, but still super exciting. It's amazing what they've done. I can't wait to see what happens next. I am going to be traveling again for my day job, and that means release of stuff will be a little bit weird. So what I'm going to do, we've got orbital news. We're going to cover that later this week. Before I leave, it'll be a short episode. It'll come out while I'm away, and then I'll talk about my time traveling there. I'm going overseas to, we'll find out soon, won't we? You'll find out on the next episode. So thank you for joining us. As always, todayinspace.net. You can follow the podcast at Today in Space Pod on Twitter and Instagram. You can follow our 3D printing. Check out the actual 3D printing of this Starship here and learn about, you can actually find the link too for the astronaut design on Thingiverse. We'll have that there. We'll have that in this episode. Apple Podcast, Spotify, YouTube, Steemit, DTube. We are on all these platforms. Happy to spread science and space science communication. There's a lot going on, folks. I hope you have a great week. Be safe, and we'll catch you on the next episode. See you later.